solved this system by graphing. In other words, I took the first line, graphed it, second line, graphed it, and the point of intersection was a solution right here. This is a solution. What I'm going to teach you now is how to solve a system, not by graphing, but by method. It's right on your notes. The method is called substitution. We'll solve the same kind of system, but just with a different method. Look at step 1. Solve one of the equations for one of the variables. I'm going to do that for you right now. Step 2. Substitute the expression from step 1 into the equation and solve for the other variable. And then step 3, substitute the value from step 2 into one of the original equations and solve. Let's try example 1. Flip your page. So this is in front of you. Flip your page and there's example 1 on the back. You're going to write on your own paper. Here we go. So example 1's on the back. Rojo, can you read step 1 for me again? Okay. So I got two equations. It says solve for one of the variables, which means get one of the variables by itself. Did I give you one? You got one? We're good? After I'm done with the notes. Yeah. It'll be Huerta than you. It's going to be all right. So solve for one of the variables means get one of the variables by itself. The cool thing is that's already done on example 1. Look at y is by itself, so y is solved for. Huerta, can you read step 2 for me? All right, so I know y is equal to 5 plus x, so what I'm going to do is on the top equation, wherever I see y, I'm going to replace it with 5 plus x. Right, Philo? Got the floor here. No devices out. Earphones off. So if I know y is 5 plus x, wherever I see 5 plus x, I'm going to replace y, or shall I say substitute y with what y is. Y is 5 plus x. So look what I'm going to do. I'm going to rewrite this first equation. 2x plus 2y. Look at 2y means 2 times y, but y is 5 plus x. Look at, I'm going to replace y with 5 plus x and write the rest of the equation. So I replaced y in the first equation with what y is. Y is 5 plus x. We know that's what y is. Y is 5 plus x, so I replace y with 5 plus x. And now I'm going to solve for x. This is math 1 stuff. I have a parentheses. What can I do with the number outside? Gracias. Here, here. Remember math 1 days? Let's rock and roll. 2x plus 2 times 5, I want to say is 10 if my coffee is kicked in. Right, Lepe? 2 times x is 2x equals 10. Nice. Let's try to remember our math 1 days now. Now what? Combine like terms. Two x and 2x, I want to say is 4x if my coffee is kicked in, plus 10 equals 10. So I got 4x plus 10 equals 10. Let's get x by itself. Let's subtract 10 from both sides. How about that? Math 1 days, pre-algebra days. Let's get x by itself. I got 4x equaling, what's 10 minus 10? Gracias. Let's get x by itself. Both sides by 4, right? Look at by x is 0. Ibarra, can you? I just did what Miss Huerta read. I substituted y. Look at y was 5 plus x. I put it into the first equation and I solved for x. Look at, I know what x is now. X is 0. Ibarra, can you read step 3 for me now? Last step. Nice. So substitute x equal to 0 into one of the original equations. The original equations are right up here. So I can replace x with 0 right here and then solve for y. Or I can replace x with 0 right here and then solve for y. It doesn't matter. I'm going to do the one that's quicker. The second equation, I just replace x with 0. I'll know what y is. I'll put it in red. So y is equal to 5 plus 0. 5 plus 0 is 5. Unless my coffee is, something's wrong with my coffee. So y is 5. We found our solution, ladies and gentlemen. Remember the point of intersection? We didn't even have to graph this system. I didn't graph anything. All I did is use substitution, and I know my x is 0 and my y is 5. Done. I didn't have to graph anything. We solved the system by substitution. Now, if I were to graph it, you would see that both lines would intersect right there. A couple more, and we're done. You guys are doing good. You guys are doing good for Wednesday, I must say. You guys are doing real good for Wednesday. Okay, we're not going to do all those examples. Let's go on and skip to number 6. Right, Wattis? Look at number 6. Wattis, read step 1 for me. The other side. Cool thing is that's done already. Look at y is already solved for. You know what a variable solved for if it's by itself. Look at y is by itself, so I know that y is 2x plus 5. Moradas, read step 2 for me.
So this is the expression from step 1 into the other equation. Solve
In other words, this expression, 2x plus 5, I'm going to replace it into y on the first equation. Because what y is, equals means is in English. Y is 2x plus 5. Well, if that's what y is, I'll replace y with 2x plus 5. So I'm going to do exactly what Moradas told me. Here we go. Let me rewrite 3x plus y, but instead of y, I'm going to write 2x plus 5 equals negative 5. Nice. This is number 6. So I'm skipping down to number 6. I'm not going to do all the problem. It's not totally unnecessary. I'm still not done with what Morales read. He said now to solve for the variable. Let's solve for x. Let's see. 3x and 2x. That's like terms. That's 5x. Nice. 5x plus 5 equals negative 5. All right. Let's get x alone from Math 1 days. We'll subtract 5 from both sides. Careful here now. Watch. 5x equals, what's negative 5 minus a 5?
Negative 10.
Thank you, sir. Right? Negative 5 minus 5 is the same as negative 5 plus negative 5, which is negative 10. Right, Dorado? Phone's away. Thank you. So let's get x by itself. I'll divide both sides now by the number next to x, which is 5. By 10 divided by 5 is 2. But the signs are different, it's negative 2. Nice. I know what my x is. It's negative 2. Now I got to find y, which is step 3. Chop, read step 3 for me.
Substitute the value from step 2 into 1 from the original equation.
Nice. Substitute this value, that's step 2, into one of the original equations up here. You pick. My suggestion is pick the one that's quicker, but it doesn't matter which one you pick. So I know x is going to be negative 2. So I'm going to use this equation because look at y is already by itself. I'll just replace x with negative 2 and then roll in. Here we are. Y then, look at y equals, wherever I see x, replace with negative 2. So it's 2 times negative 2 plus 5. So y then is going to be, order of operations, do multiplication before you add. So 2 times negative 2 is going to be a negative 4, plus a 5, positive 1. Okay, there's our solution. If we were to graph them, that's what those two lines would intersect, but we don't have to graph. We don't have to graph anymore. We're using a different technique. The last one, I'm going to go fast now.
I'll pass.
Ready? Let's skip all the way down to number 7, the next one over. Last one. By the way, that should look familiar. When did we do this one? That was warm-up today. But we graphed each line for warm-up, but now we're going to do substitution. You're going to see we'll still get the same answer. I'm going to go fast now. Step 1, look at y is already solved for. I'll replace that into right there. So I'm going to rewrite the first equation, but instead of y, I'm going to replace it with negative 2x, because that's what y is. Look at negative 2x equals 2x plus 8. So I rewrote equation 1, but instead of y, I replace it with negative 2x. Okay, so let's get x's on one side, because right now I have x's on both sides. Remember on Math 1 days? If you have x's on both sides, there's something you do to get them on one side. Let's subtract 2x from both sides, because that'll get the x's on one side. I need to get x's just on one side only, on both. Watch what happens. 2x minus 2x is gone, so I have 8 on the right side. Negative 2 minus a negative 2 is going to be a negative 4x. So the reason why this method is called substitution is because I keep substituting stuff with other stuff. I first substitute y with different stuff, which is negative 2x. And now I'm getting x by itself. And once I get x by itself, I'm going to substitute that back into one of the original equations. 8 divided by negative 4 is a negative 2. Nice. That was easy. Look at, let's figure out our y now. There's a point of intersection. X is negative 2. Let's figure out y. We kind of already know what y is because remember we did it for warm-up. It's right here. We know x is negative 2. We know y is going to be 4, but let's just verify. Watch. That was a warm-up. That step 3 says take this value and plug it into one of the original equations, either right there or right there. You pick. Doesn't matter. It does not matter. You get the same answer. What x is. I'll put in the second one because it obviously looks easy. Y equals negative 2 times x. I know x is negative 2. So y equals positive 4. Ladies and gentlemen, we just solved it. Done. That's exactly what we got for a warm-up, but substitution method.